Hey, welcome back again to Max Made Easy with Abby, where hatred of Max turns to love. So, in the previous video, we saw about cardinality of set. So, cardinality of set is nothing but returning the number of elements inside the set. So, if you want a detailed analysis of cardinality of sets, check out the previous video, which is in the description below, which is now available on the annotation above, or check out my channel. So as said in the previous video, we'll be looking on the types of set in this session. So we have plenty of types of set where we won't be discussing all these sets in just one video. So we have split it into 2 or 3 videos. So let's get into all types of set one by one in detailed. So the first set is nothing but the empty set. So can you even imagine a negative number or a number which is greater than 6 in this die? So obviously you can't do that. Such a set is called as an empty set. So this empty set actually has other names to be called, like you have empty set, you have void set, and you have the null set too. So you also use a special symbols for empty set, which is nothing but the letter phi and just enclosing a empty curly bracket. Note that empty set has much more value than all the other sets. Pretty nice, no? The next set we will be seeing is a singleton set, where a set which contains only one element, not more than one, not less than one, exactly one. The cardinality of that set is just only one. So that particular set is called as a singleton set. So let's see some of the examples. The set of even prime number, as we saw in the last video, is nothing but the element 2, which is actually a singleton set whose cardinality is 1. And likewise, let's consider the other examples too, where set of x such that 3 less than x less than 5, where x belongs to natural numbers. So the natural number which range from 3 to 5 is 3, 4, 5, and we are not supposed to include the end points. So 3 and 5 are omitted, so we are left only with 4. So 4 is the only element which you can include in this set. So there is only one element, so that's going to be a singleton set. Remember that the set x such that 3 less than x less than 5, where x belongs to real number, is not a singleton set. Just now we saw the set where x belongs to natural numbers here is a singleton set, but the x belongs to real number is not a singleton set. Guess why is it so? Pause the video, guess why it's so. So glad if you had paused the video and checked it over, or if you haven't passed, no problem, I'm not going to hate you. Right. So let's consider the real number line here. So you have which is a real number line which actually extends from plus infinity to minus infinity, right? So you all know that a number line actually contains negative numbers, 0 and positive numbers. Do you ever actually looked closer into it? So guess what's the height of yours? Maybe 179.9 centimeters tall. Where did that 0.9 come from? Check it out. So let's closely look at 0 and 1. So you have 0 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and it actually extended to 1, right? And if you again look closer on 0.1 and 0.2, you might get 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19, and 0.2. And if you again look closer between 0.12 and 0.13, you get 0.121, 0.122, 0.123 and so on up to 0.129, and after 0.129 it's 0.13, and even I can't say after 0.129 0.13 comes, because there are actually infinitely many numbers inside those two as well. Again, if you want to extend from 0.124 to 0.125, you have so much of numbers, right? So this is actually real number line, and guess what? The whole lot of numbers we discussed lie between 0 and 1. You can find many infinite numbers between just two intervals. So that's why I said the set X such that 3 less than X less than 5 belonging to real number is not a singleton set. Those are infinite set. Moving on to another type of set called the finite set, where you have countable number of elements. So we were discussing that natural number between an interval is finite, but real number between an interval is infinite. So let's bring it as a set. So finite set is nothing but a set which has countable number of elements, where we saw vowels in English alphabet. So A, E, I, O, U, you have 5 elements there, so 5 is countable, so it's a finite set. And again, let's take the set X, where it's a collection of elements X such that X belongs to natural numbers and 1 is less than X less than or equal to 3, which is nothing but this set 2, 3, where it has the cardinality 2. So this set is a finite set. Note that whenever cardinality exists, that set is called as a finite set. Moving on to infinite set as well, since those are opposite set. So a set which contains infinite number of elements is called as an infinite set. So let's take the second example first, and we'll move on to first example. So the second example says that the set of 5x such that x belongs to n, which is nothing but fifth multiples of natural numbers. Those are 5, 10, 15, 20, 25, 30 and whatnot. You can get up to 100, you can get up to 1000 multiple of 5 too. So those are uncountable, so those are infinite set. Let's consider the first example now. So the set of all points on a line. So given a line, and let's mark points on it. So let's mark a point here, let's mark a point here, and again let's mark a point, at the middle, and let's mark a point again in the middle of the first 2 points, again in the middle of the first 2 points, again in the middle, again in the middle, and whatnot. We can mark a point again from the end 2 points, and again in the middle of between these 2 points, and in the middle of again these 2 points. So you can draw a number of points just in a line. So the set of all points in a line could be an infinite set. And let's form a word jargon now. The set of all points on the line is infinite, but the set of all line in just one point, let's just interchange those two words. So the set of all lines on a point is also an infinite set. Like, let's just consider one point. Let's draw as many lines as possible passing through that point. Yeah, we have infinitely many. So the set of all points on the line is also an infinite set, but the set of all lines on a point is also an infinite set. Let's actually stop up to this. This seems too heavy, so let's continue with the types of set again in the next video, so stay tuned. This is Max May DC with AB signing off. Ta-da, bye-bye. Take care.